Alright, here we're going to be talking about exponential functions and basically just the definition of what an exponential function is, and then an example of just evaluating an exponential function. Right, so the definition: an exponential function with base a defined as f of x equals a to the x power for all real numbers x, where a is greater than 0 and a is not equal to 1. Alright, so basically what an exponential function is you have some base a, right? So that's your base number, the number that's being raised to the power. Now that base number has to be greater than 0, so it has to be a positive number, and it cannot be equal to 1, right? So an exponential function never has a negative number as the base. It's always a positive base, and then we say that it can't equal 1 because if you have 1 raised to a power, right, it wouldn't matter what x is, because 1 raised to any power just always equals 1, and then that's not going to be an exponential function, right? If it was 1 to the x power, that always equals 1, and the graph of that would just be a horizontal line at y equals 1. Right, so that's the one exception. The a, though, could be any other positive number as your base raised to the x power. Right, so what makes something an exponential function is that the variable is in the exponent. Right, you've probably seen other functions where you have exponents involved. You know, an x squared, right, a quadratic function with an x squared, that has an exponent in it, but it's not an exponential function. Right, an exponential function, the variable, the x, or what other variable you might be using, is actually in the exponent. That's what makes it an exponential function. Alright, so that's the definition of an exponential function, just a base raised to a power. Now this is the most basic type of exponential function, just a base, you know, like the example here, f of x equals 3 to the x power. That's as simple as an exponential function can get. Now you can get some other things involved. You can have some number multiplying out front times the 3 to the x. You can have this, you know, something added or subtracted to this. You can have addition or subtraction or multiplication or division in the exponent with the x, right? So exponential functions can get more complicated. This is just the most basic form of an exponential function, f of x equals a to the x power. All right, and so the example here, we have f of x equals 3 to the x power. And as far as the definition is concerned, like I'm going to do another video after this one where I talk about what the graph of an exponential function looks like in the domain and range and all that stuff. So check out that video to see that stuff. This one is this is the definition of an exponential function. Now let's see how it looks. All right, so one exponential function, f of x equals 3 raised to the x power. All right, the variable x is in my exponent. That's how I know that it is an exponential function. All right, so I want to evaluate this exponential function. So for part A, I want to find f of 5. Well, f of 5 would be 3 raised to the 5th power, right? Just like when you are evaluating any other type of function, whatever number is in the parentheses there in place of the x, right? You put that number or that expression or whatever it is in place of the x, right? So f of 5 in this case is going to be 3 to the 5th power, and then there's two ways to go about this. You could multiply 3 times 3 times 3 times 3 5 different times, right? Remember, exponents mean repeated multiplication, right? So 3 to the 5th power literally means 3 times 3 times 3 times 3 times 3, right? 5 3's multiplied together. Or you can just type in your calculator, you know, 3 to the 5th power, which equals 243, right? And to do exponents in the calculator, there's like a little caret button over here. On my calculator, it's right above the division key. There's that little caret thing for the exponent. So 3 to the 5th power gives me 243. Now, if you have a different type of calculator, your exponent button obviously would be somewhere else, probably. But any type of graphing or scientific calculator has an exponent button on there somewhere. You just have to find it. All right. So 3 to the 5th power equals 243. That's f of 5. Right? F of negative 2/3. Well, f of negative 2/3 means 3 raised to the negative 2/3 power. Right, and since we're dealing with exponential functions here, you might want to go back and review some of the laws of exponents. I did several videos about the laws of exponents and, you know, what it means when you have a positive exponent or a negative exponent or a rational, you know, a fraction exponent. Remember, a rational exponent means you're taking a root, right? So this actually means we're taking the 3rd root of 3 and raising it to the 2nd power, and then that negative out front means we're taking the reciprocal of it and flipping it all over, right? So it's 3 to the power parentheses negative 2/3. Just to show you how I type that in. If your calculator is like mine and when you hit that caret button, so some calculators are a little bit fancier. When you hit that exponent button, it actually puts like a little box up above, like up in here, so that you actually can type an exponent and it's in that position. If your calculator is like that, then you don't have to put the parentheses there like I did. But if yours is like mine where it just gives you the caret, then if your exponent contains more than just a single number, you need to put the whole thing in parentheses. In this case, the negative 2/3. I need to put the negative 2/3 in parentheses so that the calculator knows that that entire expression is my exponent. And I get 3 to the negative 2/3 equals 0.4807, and so on. Right? That's going to be an irrational number. Right? Just to show you what happens if I don't put the parentheses there, if I do 3 to the power negative 2 over 3, and I type that in without parentheses, notice that I get a completely different answer, which is the wrong answer. Right? When my calculator is doing on that second one there, it's following the order of operations, right? So it's doing the exponent before it does the dividing. So it's going to do 3 to the negative 2 power, get that answer, and then take that answer and divide it by 3. Right? Remember, your calculator is very literal with the order of operations. It does the PEMDAS, parentheses, then exponents, then multiplying and dividing, then adding and subtracting. Right? So for that second one, it does the exponent first, 3 to the negative 2, takes the answer divided by 3. Whereas in the first one I typed up above, the 3 with the negative 2/3 in parentheses, it does what's inside the parentheses first. So it does the negative 2/3 and then raises 3 to that power, which is what we want it to do, right? Because that negative 2/3 is in the exponent. So when you're using your calculator to evaluate these things, especially for exponents that involve fractions, make sure you put them in parentheses. All right, so anyway, 3 to the negative 2/3 power, the correct one was approximately 0.48075. Let's say. All right. So that's my approximation of 3 to the negative 2/3 power. Right. And again, what that means is, this is, it would be the third root of 3 raised to the second power, and then the reciprocal of that. Right. Based on this exponent. And again, if you don't understand what I'm talking about there, go back and review the rules of exponents, because that's where we cover what the negative 2/3 power actually means. Right. But that would be like the translation. And if you type this in, you should also get that same answer. All right, it's the third root of 3 to the second power, and the negative exponent means flip it over. All right, next one, f of pi. All right, well, this is a little weird, but that means 3 raised to the pi power. All right, now, remember, exponential functions is defined for all real numbers x. Right, so 3 to the 5th power, right, remember, that's just 3 multiplied 5 times. Right, when your exponent is a positive whole number, that's pretty easy to figure out. You just multiply that base number that many times. When it's a fraction or a negative exponent, we also know what that means if we recall the laws of exponents, and we could, write an expression to show what we're getting here. Excuse me. But for 3 to the pi power, like, how do I multiply 3 times itself pi times 3.1415, whatever number of times, right? That one is a lot harder to represent in a form like this or like this, but still, it exists, right? The exponential function exists for all real numbers x. So for one like that, where the exponent is an irrational number, in that case, you just have to put it into the calculator to figure out what 3 to the pi power equals. All right, and once again, if you have a scientific or a graphing calculator, you should have a pi button. On my calculator, if you look above the exponent caret there, in blue, it has the pi symbol. Right, so I hit second and then the exponent button, and that gives me pi, and then we get 3 to the pi power equals 31.5442807. So that's approximately 31.544. All right, and we're not told in this problem how many decimal places to round to. If you are doing a problem and it says, evaluate this and round to 4 or 5 or 6 decimal places, just make sure you follow the directions. This one didn't give us any directions, so I'm just finding a convenient place to round off the answers and calling it that. Right, now, remember, pi is a little bit bigger than 3, right? It's 3.14, approximately. Well, we can kind of estimate here. So what's 3 to the 3rd power? Well, 3 times 3 is 9, times 3 again is 27. Right, so 3 to the 3rd power is 27. So 3 to the pi power should be a little bit bigger than 27. Right, so 31.544 kind of makes sense that would be 3 to the pi power. Right, the last one here, f of the square root of 2. Right, so that's 3 to the power square root of 2. Right, again, square root of 2 is an irrational number, and so we just use our calculator to figure out what this is. Right, so 3 to the power square root of 2, and we get whatever that is, 4.7. I can't really read the rest of it backwards. It's 4.72880 and so on. So let's call it 4.7288. That's approximately what 3 to the square root of 2 power looks like. All right. So that is again, the definition of an exponential function, right? We have a base number that's a positive number other than 1 raised to the x power. That's the basic form of an exponential function. And when we need to evaluate an exponential function, just whatever number's in the parentheses, we just put that in place of the x, just like when you're evaluating any other function. Sometimes you can do it by hand, if you have a positive whole number exponent generally. Other numbers, though, negative fractions sometimes, or irrational numbers, we have to use a calculator to evaluate exponential functions, right? And when you're dealing with exponentials and logarithms, which is something that we'll also talk about soon, a lot of times in order to evaluate them, you do need to use calculators to do that. It's usually not the kind of thing that you can just do by hand or do in your head like you can with some other types of functions. All right, so that's it for the definition of an exponential function. Check out the other video that I'm going to do, which is all about the graphs of exponential functions and the domain and range and all that stuff. So the two videos that I'm doing on these kind of tie together, so make sure you check out that other one as well.